A definitive numerical demonstration that 1 is not equal to 0.9999 ad infinitum. My motto: plain honesty, simple truth, easy understanding, the joy of finding things out for yourself. I swear on the book of Euclid's Elements that the demonstration I am about to present is the truth, the whole truth, and nothing but the truth. The establishment's pretense for the proof: let m1 equal 0.9999 ad infinitum, multiply by 10 and subtract m1 to give 10m1 equals 9.9999 ad infinitum, subtract 1m1 equals 0.9999 ad infinitum to give 9m1 equals 9, therefore m1 equals 1. The weakness or deception of the proof is that 10 equals 10 times 1 is equal to 9 plus 1, and whilst it makes a pretense of multiplication, it actually uses the addition option, because, as I will show, the answer it gives after subtraction can only result from addition and definitely not multiplication. So the decimal expansion with or without the residual is unchanged and self-cancels on subtraction. First, an opening statement on just what is infinity. Infinity is nothing more or less than just a never-ending stepwise process that can proceed without end for eternity. It can be applied to magnitudes, large or small, linear and volumetric measure, and to time, to name a few. Because we are brought up on base 10 arithmetic, a good and adequate representation for infinity is 10 to the power n plus 1, for n equals 1, 2, 3, 4, 5 ad infinitum, because it implies that no matter how large n, there is always one more step to be taken. Secondly, the advocates for 0.999 being equal to 1 maintain that as it gets infinitely small, the difference between it and 1 eventually becomes 0. Yet another falsehood, since the difference, alias the residual, is always present and equal to 1 over 10 to the power n, no matter how large n, i.e. 1 minus 0.9999 ad infinitum equals residual, QED. 3. The next slides, 6 and 7, that follow show the stepwise infinite series expansions for 1/3 and 1. Again, the advocates maintain that multiplying the series for 1/3 by 3 gives 0.999 ad infinitum, which must therefore equal 1. It would be if the residual went to 0, but it cannot and doesn't, so that 1/3 times 3 equals 1, and exactly, and not 0.9999 ad infinitum. Likewise for the series expansion for 1, it is again a fact that the residual cannot ever become equal to 0. Six. The derivation of the infinite series for 1 shown on the previous slide at 7 results directly from the algebraic identity y equals 10 to the power n minus 1 all divided by 10 to the power n, for n equals 1, 2, 3, 4, 5 ad infinitum, which gives us 9 over 10, 99 over 100, 999 over 1000, 9999 over 10,000, and 99,999 over 100,000, and so on and so forth, which reduces to 0.9, 0.99, 0.999, 0.9999, 0.99999 ad infinitum. We note that both the numerator and denominator are integers, both of which can be extended without limit. the algebraic identity can be restated as y equals 1 minus 1 over 10 to the power n, which again gives the stepwise infinite series 0.9, 0.99, 0.99, 0.9999 ad infinitum. Seven. If we take the reciprocals of the individual steps, then we get the infinite series at each step as shown below. It is self-evident that as the series of 9s becomes infinite, that the reciprocal becomes 1 plus ad infinity of infinities of zeros, all separated by 1. Instead of just the solitary 1 equals 1 over 1, we would expect, again a contradiction, that 0.999 ad infinitum equals 1. Eight. Addition. 9 plus 1 equals 10. Multiplication. 10 times 1 equals 10. Addition. 9 plus 0.9 equals 9.9. Multiplication. 10 times 0.9 equals 9. Addition. 9 plus 0.99 equals 9.99. Multiplication. 10 times 0.99 equals 9.9. Addition. 9 plus 0.999 equals 9.999. Multiplication. 10 times 0.999 equals 9.99. Addition. 9 plus 0.9999 equals 9.9999. Multiplication. 10 times 0.9999 equals 9.999, and so on and so forth ad infinitum. This proves that step-for-step multiplication gives a series that is one step less and therefore 10 times bigger than the original series, as is also the resulting residual. Yet another deception. Note, the three appended dots of the establishment implying infinity have absolutely no mathematical meaning or consequences. Nine. So, to conclude, it has been absolutely demonstrated that the infinitely expanding series 0.9999 ad infinitum cannot be multiplied without any regard to the expansion, which must become a fixed length at the time of multiplication, and which will then decrease in length by one step for each multiplication by the lowest common multiplier of the denominator, which is 10 for this series. It is not therefore legitimate to simply subtract the decimal series m1 from the decimal fraction m10 after multiplication, say that they are both infinite and therefore equal, so that the result must be 0. Wrong, and yet again a deceit. Hence it is shown that 0.99999 ad infinitum is only an approximation and not an equality, so no, 1 is not equal to 0.999999 ad infinitum. QED. 1. Let no man drive us from this place. Hilbert, 1928. 2. Let no man drive me to this place. Simpleton, 2024. The bit that follows now on the next 3 slides has been taken from a previous video on this topic, and which I think is rather interesting, so I'll show it again. Take the recursive equation x equals 2x minus x squared and feed the answer repeatedly back into the equation. When x equals 0.9, the sequential answers are as given, a doubling of the digits at each step. When x equals 1, the sequential answers are, again, the same as above and a doubling of the digits at each step. Make of it what you will, but it tells me that the decimal sequence can be doubled indefinitely without any error term as per 3 times 0.3333 ad infinitum plus error equals 1, and can therefore always be subtracted from 1 at any step to obtain e. So for me, 1 is not equal to 0.999999 ad infinitum. So that's all, folks. Hope you enjoyed the maths, and thank you for watching.